I actually think we're right on the cusp in the 3D printing world of something that I would call smart bed leveling. Basically the idea that you could actually enter in your filament into your slicer settings, send that off to the printer, and then through a combination of hardware and software, your printer would actually be able to determine the perfect distance between the nozzle and the bed in order for you to get the perfect first layer. We're actually super close. Let's take a look at where we're at and where we need to be. Hi there, my name is Nils and welcome to the 3D Printing Zone. Now recently, FlashForge sent me their latest printer. This is the Adventurer 4, and I noticed in the advertisement that it claimed to be leveling free. And I thought, what does that mean? Is it actually leveling free? Have we reached that point where we don't have to worry about bed leveling at all anymore? I'll get to more of that in just a second, but it made me think, what are the levels of bed leveling that we've experienced so far in the last several years, and how close are we to actually being to a point where we really don't have to worry about it, and everything is done in the software and the hardware. Now I've broken this down into 4 levels of bed leveling, the first being the most basic and maybe the least user-friendly, and the fourth being what I would consider smart bed leveling. So on the first level you have what is fairly traditional, especially on less expensive printers and older 3D printers. Something like the Ender 3, for example. On here, this is the Ender 3 V2, and you have some springs that are underneath each of the corners of the bed, and you can raise or lower the bed that way. On the x-axis, your hot end with a nozzle will move along, but it doesn't go up or down. There are no sensors. It's kind of a dumb nozzle, basically. And so it's really up to you to move the bed to the right proximity to the nozzle. That's your only option. That's how that one works. Now this is probably the most common type of bed leveling out there, and it's on all kinds of printers. The low-end printers that don't have the upgrades, on the older printers, your budget versions, everything like that. But there are 3 main issues with it. Number 1, everything on it is manual. You have to sit there and adjust, use the piece of paper, dial that in, and then go around sometimes 2 or 3 times around the corners and the middle to try to get that just right. So that's one issue. The second issue is that the bed itself moves. When you're on springs, if you put a little pressure on there, if something shakes or moves, it has a tendency to come out of whack a little bit. So there's that failability there. And number 3, the nozzle and the hot end itself is dumb. It really doesn't know where the bed is in relation to it, and that causes a problem. Now one level up from there on level 2 is the ability to add some smarts basically to your hot end. This is a BL Touch. This is actually a knockoff BL Touch, but it's a probe or a sensor that will detect what the distance is between the nozzle and the bed. And that adds a whole new level of capability to the printer when it comes to bed leveling. Now if you've still got that bed on springs, you still have that issue, and we still have some manual adjustments to take care of. So that would bring us to level 3. Now moving on to level 3, we have a printer like this. This is the FlashForge Adventurer 4, and with this one it has a very thick and stable bed, especially on the Z-axis. The bed itself, which is removable, actually sits on an 8mm thick plate. It's a metal plate, and that's about 5/16 of an inch. And that's guaranteed to not vary more than 0.15 millimeters on the surface of that. So it'll keep things nice and steady. It's got 2 thick rails, so it slides along, and that Z-axis should always be at the same height for the bed, no matter where you move it. So that's one way to keep everything totally stationary down low. That gets rid of that one issue of the bed being able to move around. What it doesn't have is any sort of sensors that I'm aware of anyway in the actual hot end. The hot end comes down, you do your same kind of manual leveling in order to get it to the place it needs to be, and you use software to compensate for this. This is a super common technique. Anything that says auto leveling typically isn't auto leveling. It basically just means there's software compensation for the height off the bed. You just tell it how high off the bed you need it to be, or it could use the BL Touch or something like this, a sensor like that, in order to find that. Now I don't want to sound like I'm knocking on what this is doing, because actually this is one of the easiest and most stable printers I've used when it comes to bed leveling. The fact is, I've moved this printer all around this room probably 5 or 6 times now, manhandled it around, carried it, put it down on the floor, put it up. I leveled it the first time that I used it. When we unboxed it and got it set up, I leveled it using the system that's in the touchscreen there, and I haven't had to do it since, and I haven't had a single issue with the prints. I've probably only done 15 or 20 prints on this so far, so it's not like I've done, thousands of hours with it, but it's been flawless. Because I think we don't have to deal with the springs underneath there. There's no movement, there's no possibility for that to go anywhere, and so that software compensation that we talked about does a really nice job at just knowing exactly how far off the bed to be. So let's talk about the future, and again, what I would call smart bed leveling that's way up here as far as what it can do compared to what we see today. You take a printer like this that has a very solid bed. You're not going to have a lot of tolerance on the height of the bed, and you know that face is going to be perfect. Then you add a sensor to the hot end, so you make that smart by itself. You've got a hardware combination here that's really setting you up for success. That's the first part. The second part of that is the software, and that software has to exist both in the slicer and in the printer itself, in the firmware. And ideally, you'd be able to put in whatever type of filament that you're using, and it would know exactly what that height off the bed needs to be. And ideally, you can mess with that a little bit yourself. Say you have some custom settings you want to do, or there's new filaments that come out, you'd be able to input that into the slicer as well. Now, when we get to that point, I think we've achieved first layer nirvana. I think that a lot of the issues that we see with that first layer will be taken care of with a setup like that. And this one is so close. I think we're just missing that sensor and that software to help us out with that. Now, speaking of the future, I thought it would be fun to take a look about 5 years into the past and see how much 3D printing has changed. And for that, I've busted out my old pal, the old trusty PrinterBot Simple Metal. This is my first 3D printer. I will probably never sell this because it's kind of nostalgic for me. It's only been 5 years, but so much has changed. In fact, this printer cost about $700 when it was new. I had to get wife permission to get this. I had to save up a little bit, and it was like an investment to get this thing. But I went ahead and got it, and believe it or not, our sponsor for today's video, FlashForge, has their new printer, the Adventurer 4, that's $799. 99 bucks more, 5 years later. What has changed is incredible. So in old Micro Machines style, for those of you who are in your 40s or maybe older, you might remember the Micro Machines commercial where the guy spoke about 1,000,000 miles a minute.
This is the Micro Machine Man presenting the most midget miniature motorcade of Micro Machines.
And I cannot speak quite that fast, but I thought it'd be fun to do a quick rundown of only the things on the Adventurer 4 that are either better than or that the PrinterBot Simple Metal just didn't have at all. I don't think I can do this in one breath, but I'm pretty sure I can do it in two. Here we go. 9-point bed leveling compensation via software, 8mm thick super flat bed base, 3-second nozzle swap. I must be slow because it took me 5 seconds. Nozzles heat up to 200 Celsius in just 60 seconds. Dual Y-axis guide rails, dual Z-axis lead screws, fully enclosed with 3 viewing windows, HEPA 13 air filtration built in, enclosed 1 kilogram filament spool holder, LED light inside the printer and on the hot end, a 200 by 220 by 250mm print volume, flexible magnetic and removable platform, leverages the all-new FlashForge 5 software with remote control and remote monitoring. Prints can be sent via Wi-Fi, Ethernet, USB drive, Flash Cloud, or Polar Cloud. Prints up to 150 millimeters per second. Records time lapses of every print on the included HD camera. 4.3-inch color touchscreen, built-in Wi-Fi, power failure resume, filament runout sensor, energy saver mode, 12-month warranty, full-size USB-A slot, 1 kilogram PLA included. Comes fully assembled and ready to print. Receives over-the-air firmware updates and costs just $799 US. Pretty cool. So we've come a long way from 5 years ago till now. Everything I just mentioned on there is something that this printer does not have, and for $99 more than what I paid 5 years ago, you get all that this has. That's pretty impressive. I printed this Darth Vader bust on it with the stand. I printed this stand for my Oculus Quest 2 headset and a bunch of other cool stuff, and I'm very impressed with it. It's a great little printer, and especially if you just want something that's going to be no hassles, give you all the coolest features, and just work. If you want to see more, check out links in the description below. So I'd love to hear what you think. Are we maybe as close as I hope we are to having smart bed leveling in our near future? That does require some minor updates to the hardware that I think we're pretty much there on, and maybe there's something out there, printers out there that are doing all of the things that I mentioned that I'm not aware of. But then we have to get the software developers on board, both for the firmware and for the slicers. So are we close? Are there other things that you'd love to see in a 3D printer that you think we're really close to and maybe should have? Let me know in the comments section below. Now, while smart bed leveling is not here just yet, there are a couple of techniques that I've outlined in this video right here that show you how to nail that first layer and get it perfect. My name is Nils with the 3D Printing Zone. Thanks for watching, and we'll see you on the next one.